Today we're going to be talking about the anatomy of a lake and the anatomy of an ocean. Let's go ahead and start with the anatomy of a lake. We're going to start by drawing a nice bowl, and this is going to represent our lake. So there it is. And let's go ahead and add a little water to our lake. There we go. And on the sides, I want to add a little bit of vegetation. A little above the water, a little below the water. And this is where we're going to start with our anatomy. So the first part of our lake, right here where vegetation grows, this is going to be referred to as the littoral zone. This is where the vegetation grows. And you can see the littoral zone also over here. Now think about this. This is three-dimensional, so this littoral zone is going to come out at you, and it's actually going to encircle the entire lake where vegetation grows. So that's going to be our littoral zone. Now from there, we're going to go ahead and we're going to break our water up into two groups. The upper group is going to be called the photic zone. The upper layer is going to be called the photic zone or limnetic zone. Because this is where light enters the water. This is where you can see. So if you were a scuba diver, you could actually swim around here and you could see just fine. Now that has some significance because where there's light in the water, photosynthesis can take place. So you've got algae around here, you've got water plants around here, and they're all photosynthesizing, and one of the photosynthetic products is going to be oxygen. So this layer is going to be rich in oxygen, one, due to photosynthesis, and two, because it's in contact with the air. So you get mixing of air with the water. So we're going to have lots of oxygen in this area. Now the area of water down below, this is going to be the aphotic zone. A means without light. We could also call this the profundal zone. And there's not going to be any light down here. So where there's no light, there's no photosynthesis going on. And because of that, we're going to have very, very low oxygen conditions. Not a lot of organisms are going to be able to handle these low oxygen conditions. So there's going to be some aquatic life, but not a ton down here. Now, let's take a look at the very bottom of our lake. This is going to be the muddy bottom. So let's go ahead and accentuate that a little bit. And this is going to be the muddy bottom, all through here. Muddy, muddy, muddy bottom. And this muddy bottom is going to be called the benthic zone. And benthic zone is going to be our muddy bottom. Now we can also break up this lake into three parts based on temperature zones, or temperature layers. And the fancy word for layer is limnion. Limnion means layer. And we're going to talk about temperature layers. So we're going to divide this lake up into three limnions, or layers, based on temperature. The top layer, which is going to be our warm water, is going to be referred to as the epilimnion. Now, epi means above or on top of. This is going to be our nice warm water. And then we're going to have another layer, a more narrow layer, which is going to be our transition zone between our nice warm water and our very cold water. And this is going to be called the mesolimnion. Now, meso means middle layer. This is also referred to as a thermocline. Now, if you've ever gone scuba diving, you know what a thermocline is. It's a sudden transition zone from warm water to cold water. Now, below that is this large body of cold water. And this is going to be referred to as the hypolimnion. And hypo means below or bottom. That's going to be your hypolimnion, your cold water. Now, this diagram looks like this in the summer mainly, when you get this stratification taking place. In the fall, what's going to happen is, especially up north, as the air cools, it's going to start to cool this top layer of water, which is normally very warm in the summer, but this top layer of water is going to start to cool. And we know as water gets colder, it becomes more dense. And as winter starts to approach, this layer of water actually can get colder than this bottom layer of water. And once this gets colder, this water is going to be more dense, and we know that dense water, very dense water, begins to sink. So this water is going to begin to sink and actually push this water up. So we're going to get a churning or a mixing of our lake. Now that's a good thing, because all the oxygen here is going to get distributed around the entire lake. And all the nutrients down here, because this layer, the aphotic zone, is in contact with our nutrient-rich bottom right here. And as this lake gets churned around, as this water gets pushed up, it's going to take these nutrients and mix them up too. So that when spring comes around and summer comes around next year, we're going to have a lake that is very rich in nutrients, and it's also going to be well oxygenated. And then as summer heats up again, we're going to begin to stratify our layers again. And that's it for anatomy of a lake. Let's go ahead and start talking about the anatomy of an ocean. Let's go ahead and draw our ocean. We're going to start up here. We've got our shoreline, and our shoreline steadily slopes down, and then we're going to have a nice area that's fairly level, and then suddenly we're going to drop off very precipitously, and then we're going to reach the bottom of our ocean. Now the area up here where we have a gentle slope and also where we begin to have a nice horizontal area here, this whole area is going to be referred to as our continental shelf. And where we begin to drop off dramatically, this area is going to be the continental slope. And this very bottom part of the ocean, that's going to be the abyss, or abyssal plain, sometimes it's referred to as. Now let's add some water to our diagram. Here's some water. And we're going to go ahead and we could add some vegetation. Well, this area right here, we have an upper water layer, and we also are going to have a lower water layer. And that's due to the pull of the moon. The moon exerts gravity on this large body of water and actually tugs on it. When we've got high tide, and when the moon begins to tug a lot and pull that water outward, we're going to have low tide. And the difference between the two tides is going to be referred to, or the area between the two tides is going to be referred to as our intertidal zone. Now, inter means between. So in this case, we're between the high and the low marks of water, intertidal zone. This is also loosely referred to as our littoral zone. And it's an area of very high productivity. You've got light in here, you've got a lot of mixing of the water with the air, so it's well oxygenated. You have a high net primary productivity in here. So lots of organisms growing, lots of life taking place. Now let's go ahead and divide up our ocean according to amount of light it receives. So the top portion, the top layer of our ocean is going to be called the photic zone, because that's where light penetrates. And the bottom, and by far the largest part of the ocean here, is going to be the aphotic zone. It receives no light, without light. And both of these together are referred to as the pelagic zone. This is the open ocean. Now let's add one more thing to our diagram here. Let's add a muddy bottom. Okay, so this is all going to be our muddy bottom all the way around here. And the muddy bottom, just like before, is going to be called our benthic zone. That's going to be our muddy bottom. And that's going to be it for the ocean.